In this video, we demonstrate the Repeated Measures Analysis report. The Repeated Measures Analysis is designed for any assessment that has been repeated at regular time intervals during the season. We then try to determine whether time had an effect on the assessment outcomes. We begin by opening a tutorial file. The AUDPC-1 trial is a good example to use. Let's first look at the data in this trial. We have disease counts repeated through June, July, and August. And the last column is an AUDPC transformation, calculating the area under disease progress curve on the other columns. Repeated measures is performed as a report in ARM, so select File, Print Reports to begin. In the Available Reports list, double-click on the Repeated Measures report within the Summary section to add it to our report list. There are a few options to customize the analysis and output. The first option sets the model used in calculations. Currently, ARM supports the split plot model, wherein the treatments are factor A and the assessment dates are factor B. Next, set the mean comparison test and significance level to be used in the analysis, just like an AOV means table report. The adjusted mean is always used as part of the repeated measures analysis. The next section adds descriptive statistics to each means section on the report. The first option adjusts the error degrees of freedom in the analysis, applying a correction to adjust for the correlation in repeated measurements. We lose degrees of freedom in a repeated measures situation because time is not independent, unlike in a true split plot where subplots can be independently randomized. This report can also include a correlations report and a treatment by time graph. We will discuss both of these when we look at the output. Now press the Next button to proceed to the next step. Here we define what assessment columns are the repeated measurements. First, click on a column and ARM finds similar columns based on certain matched fields. In this case, columns 1 through 5 all matched, as expected. We could also manually adjust how columns are matched to widen or narrow the selection. The status and the instructions for matching are in the middle of this dialog. If we choose a column that has no matches, then there is an error stating that more than one column must be included for the analysis. A history of your previous column matches will display on the right once you run repeated measures on different data sets. The View Selected button changes the ARM view to show only columns that are currently matched. Select this button again to go back to all columns visible. You can also set the graph options for the treatment by time graph that can be included on the report. Let's switch back to match our repeat assessments and then press Next. Now we define how to describe the data column assessments on the report. Typically, the distinguishing field would be the rating date, but others can be included as well by clicking on the prompts. When we press Next, now the report is generated. Let's preview it on the screen. This report is similar to the factorial AOV report, but where the treatments are factor A and the assessment dates are factor B. So a table of treatment means are created across all rating dates, followed by a table of rating date means across all treatments. Mean comparisons and descriptive statistics are also included. Then a third table with treatment by time means that extends a few pages down. Next is the repeated measures AOV table. This gives insight into the treatment effect, rating date effect, and the interaction between the two. Next is the treatment by time line graph, plotting treatment means over time. Use this to visually identify treatment interaction across assessments. For example, treatments 2 and 3 performed similarly in the first and last assessments, but treatment 2 was less effective during the middle weeks of the season. Or we can compare treatments 2 and 6. These two went back and forth on which was more effective through the season, while settling to the same spot in the end. The last section of the report is the correlations table, displaying all possible correlations between data column assessments. Review the residual correlation values in the table, ignoring the main diagonal. If these values are close to 1 or -1, then a correction should be applied to adjust the error degrees of freedom in the analysis. If the data is well correlated with time, then future assessments are affected by previous values, and so we must adjust the analysis accordingly. In this example, there is no evidence of a strong correlation, and so no adjustment is necessary.